curiosity, let's do a bit of a recap in formulas. I'm all about understanding, but I taught you the understanding, and hopefully now it's ingrained in your head and you've done enough to remember. We've done arithmetic sequence and arithmetic series. Series probably had more formula based in it, but you can figure it out right now. If you just think about the logic, you can figure out the formula. But let's start off easy. What is the arithmetic sequence formula again? Can I please have, let's go with Sava. What's the formula for arithmetic sequence? Forgotten? Give me the recurring, or you can work with the recurring formula. Do you remember the recurring formula? What does arithmetic sequence mean again? Yes, it does, but what makes it arithmetic? Not sure, Kynan.
Something subscript n is a bracket n minus 1.
Good. Now, the interesting, what I want to understand, yes, you're right, the formula is correct. It is Tn is equal to Tn minus 1 plus n minus 1 times d. But how do you know it's arithmetic? So we've got recurrent sequences and we have infinite sequences, but when do we have specifically arithmetic sequence? What's an arithmetic sequence? How do I know when I have one? What's the key thing? Because without it, you can't have the formula. There's something that it has to be for it to be arithmetic. What is it? The previous number, yes, but that's recurrent. I can have, let's say, Tn, let's say T1 equals to 2, and I can say the formula is Tn equals to the previous number divided by 3. Is that arithmetic? So I can have 2 on 3, and the next one will then be 2 on 9, and then 2 on 12, and it carries on. How do you know when you have arithmetic? Yes, Jamie? Requires addition. Remember, it's a constant that you're adding on. So for example, 2, 4, 6, 8, 10. What are you adding on consistently? 2, 2, 2. Because you're adding it on consistently, that's why it's plus number of 2s you're adding. Okay, that's why that formula makes sense. Okay? Same thing if you understand arithmetic sequence, which is only when you add, that's repeated addition of the same constant. See, the other formula for it was, instead of Tn minus 1, they called it A plus n minus 1 multiplied to the d, which is the distance. Distance between the two units, like how much are you adding on? The common difference is what they call it. Okay, so you got T of n. This is your arithmetic sequence formula, which makes sense. The number that you start off with, how many times are you adding it on? So for example, 2, if I'm adding 2 on each time, for the first one it's just 2. For the second one, it'll be 2 plus 2. Okay, so you get difference of 2 times 1. And then the third one will be 2 plus 2 times 2. So 2 plus 4 makes it 6. Makes sense. So you get 2, 4, 6. It carries on, yeah? Other than that, what is arithmetic series then? What is the formula for the arithmetic series? Well, first off, what is an arithmetic series? What's the difference between sequence and series? William, Dang. What's the difference between sequences and series? No? Can't in again? Fantastic. So sequence is a pattern. When you sum those patterns, so that's the first term, second term, third term, fourth term, fifth term, it goes on infinitely. When you sum all those terms together, that's called a series. A sequence is a pattern, yeah? So this pattern in specific is when you're only adding on a constant value. Next one, series. So now we know what a series is. Arithmetic means that you're adding on. Series means sum these terms together, and there was a formula for it. What was the formula again? What was the formula again? Yes, Jamie?
Sn equals to n on 2 bracket 2 plus bracket n minus 1d.
Fantastic. Okay, so this one, again, how I guess how I always understand it or how I remember it is because I know the result is coming from the proof where we're just adding on Sn plus Sn. That's why it's 2Sn. And so I know, well, it's the number of times in the proof I showed you previously it was repeated 2a plus n minus 1. And because it's the number of times you have that, I can sort of remember the net n on 2. For these two here, I know it's what you start off with plus Tn, which is your arithmetic sequence. Okay, so if you break this up, this is the same, well, is the same thing as saying a plus n minus 1 times d, and conveniently that is your arithmetic sequence. That's how I remember them. Okay, because I know that 2a is the same thing as saying a plus a, but a plus n minus 1 times d is the same thing as saying that. Okay, and that's how I remember it. So I could see it as 2Sn equals n times a plus Tn. So I think of it. Okay, but anyway, that's just a quick sort of a recap on what we've done. If you've forgotten it or if you don't know how to do them, go back and make sure to understand the difference between sequence series, what's arithmetic, and what's geometric for today. Okay, because if you understand, it's just technically, I've only taught you 4 skills. I've taught you what a recurrent sequence is. I taught you what an infinite sequence was. Recurrent is when you require the previous term. Infinite means you don't need it. So this formula now is an infinite, that's a recurrent, right? And then I taught you arithmetic means it's a specific recurrent. It's when you add on. Then I taught you series, pattern, sum of all patterns, or sum of all terms. Yeah? Now we're going to geometric. So let's go to geometric today. What is a geometric sequence? So we now know a sequence is a pattern. And it's a particular type of pattern. And the pattern is when you have multiplication. So the other one is you had to add. Every time you add 2, add 3, add -3, add -4, whatever it is, it's repeated addition. In this case, it's repeated multiplication. Okay, repeated multiplication. That's what geometric sequence is. So it's a pattern where you continuously multiply to get to the next term. So for example, 2 to get to 6 times 3. 6 to get to 18 times 3. 18 times 3 again gives you 54. So the pattern is that it's based on multiplication. Okay, so this is a sequence, it's a pattern. What type of pattern? It is a multiplying pattern. Okay, it's a repeated multiplying pattern, which means you can use what I've been teaching you using recurrent sequences and then try to transform it to an infinite sequence, and you know the formula. You don't need me to figure it out, you can do it yourself now. Okay, so I'm going to teach you anyway, just in case you don't. All right. So we know a geometric sequence, and I know they've given you that, but I don't like just taking it as it is, yeah? Let's try to think of it logically. Let's go logically. T1, which is the first term, I'm starting off with 2. To get to the next term, I'd say times it by 3. So take the old term, term 1, T1, first term times it by 3. That gives me the second term. Then I'd say, well, that means the third term would be whatever T2 was times by 3. So whatever T2 was times it by 3, I get T3. To get T4, I did take whatever T3 was, and I times it by 3. So I've got a pattern going on. This is called a recurrent sequence. That's exercise 4A that I taught you. Yeah? 4A was like, you're using the previous term. What's the problem with this? Well, if I asked you for the 100th term, what is it equal to? You can't find the 100th term unless you have the 99th. But you can't find the 99th unless you find 98, and it goes all the way back to, it takes too long. So how do you change this now to a infinite term? Okay, that's what you want. So what they've given you here is a recurrent sequence, which we can summarize here. It's like Tn minus 1 is like, so if this is T4, that's T3. T3, T2, T2, T1. Yeah, so that's why whatever this is, Tn, that's Tn minus 1, which is what they have here. Multiplied to R, what's R? R obviously is the common ratio, or that factor, common factor that you multiply, right? Our goal is to find out the geometric sequence formula, which is exactly what you did in 4A. Your goal is now to rewrite all this so you can write a formula where you don't need the previous term. And how I taught you with arithmetic is exactly the same way I want to teach you for geometric. And you can all do the same thing. So what I would do is I'd say, all right, T1 is 2. T2 is T1 times 3. Fair call. But T3, see, T3 is what T2 is times 3. So why don't I just replace that? Because I want to keep it all consistent. I don't want the previous term. Because if I don't change that T2, I'm always reliant on the previous term. So if I replace T2 with this line here, see T2, this is T2, but I replaced it with T1 times 3 is T2. So if I replace it, suddenly T2 and T3 are only reliant on T1. And that's perfect. That now doesn't require the previous term. In fact, it only requires the first term. So if I follow that pattern I do for T4, T4 is the same concept. T4 says whatever T3 is, times that by 3. So I do the same thing. I'm like, all right, well, T3 is T1 times 3 times 3. So why don't I just put it there and say times 3? That's what I'm doing. I'm just saying times 3. So the nice thing is I'm changing a recurrent sequence or formula to a infinite, as long as I know what the first term is. And so if I just summarize all that, notice this is 3 times 3 times 3. That's 3 groups of 3. This is 2 groups of 3. This is 1 group of 3. When it's 2, I've got 1 group. When it's 3, I've got 2 groups. When it's 4, I've got 3 groups. There's a pattern. And so the pattern here would then be T1, which is what you start off with, times your common ratio, which is 3. Well, 3 times 3 times 3, 3 groups, or 3 times 3 times 3 is not groups, but 3 times 3 times 3 is repeated multiplication, which we can write 3 to the power 3, 3 to the power 2, 3 to the power of 1. So I'm just short by n minus 1. So think about it. I'm just going to write here, that's 3 to the power 1, whereas this one is T2. When this is T3, I have 3 to the power 2. When this is T4, I have 3 to the power 3. And there's a pattern. So it's T4, that's 3 to the power 3. So that means if it's T100, it should be 3 to the power of 99. Logically. Okay? And so that allows me now to find out the formula, because then it's just T1 times 3 to the power of 99. That I can work out. Whereas this one, you needed to get all the way to 100. It takes too long. Does that make sense? So I'm just recapping all in one slide. I'm recapping what you learnt in 4A, how you would have found 4C, which is arithmetic, and sequences and series. And now I'm moving to geometric. Yeah? Geometric is multiplication. But if all that doesn't make sense, then I guess you got a lot of formulas to memorize. Okay, you got 4 of them now. There you go. Okay, so this is the geometric sequence formula. It tells you Tn if you want to find the next term. I know they use different letters. I'm trying to use logic for you. But the formula they give you is A, which is T1, A meaning the first term, times the common ratio, R, so what's that common factor, to the power of n minus 1. Yeah, so I'm using logic to figure it out, but you can memorize that formula if you want. It's up to you. Yeah? If you're questioning what this line here means, common ratio of successive terms, it's big numbers or big language there. All they're really trying to say is from 2 to 6, and 6 to 18, and 18 to 54, they're all of the same ratio. So what I mean is if I said 6 divided by 2, that's a ratio. 6 to 2 is the same thing as saying 18 to 6. It makes sense. 6 divided by 2 is 3. 18 divided by 6 is 3. And the same thing if I said 54 to 18, that's also 3. That's a common ratio, and that's what they're trying to say here. TK over the K previously. Okay, so 54, with the K previously, that should be the same ratio for every one of them. And it makes sense, because if you're timesing, well then you're dividing to get the same values, like saying B divided by C, D divided by C, and you're going backwards. It's like if you add, then you can subtract. If you multiply, you can divide. Yeah, so they have all the same ratio, is what we call it. That's all that's trying to say. So don't get confused by them. Don't be intimidated by that. It's just think about it logically. Common factor, what you start off with. Okay, so that's your A value, and that's your common factor there. All right? Now, let's do an example. Let's do a couple of examples. So this is the only formula we're working with today. A times R to the power of n minus 1. It's a geometric sequence. A sequence is a pattern, and this particular pattern is a multiplication pattern. Yeah? So let's work with this one. It says, find the 10th term of the sequence 2, 6, 18. So we want to find the 10th term. right? We know the pattern is 2 to 6, 6 to 18. What are we doing? What is a multiplication of? 3. Okay, so I know A, I'm starting off with number 2. T1 is 2. Common factor is 3. So, common factor, or common ratio. Times it by 3. My formula is given by this. I want to find T10th. It's the 10th term, so T10. T10 would mean then A, which is 2, R, which is 3, that's my common ratio, to the power of n minus 1, so 10 take away 1. And that gives me 2 times 3 to the power of 9. Use a calculator, don't do it by hand. And that gives you 39,366. Simple and easy. How do we feel? Good? Summarize everything for chapter 4 so far. A, B, C, and D. Boom, boom. Now, let's move on to another problem. Same thing. Remember, you're just using one formula, and what they're trying to test your skills. They're trying to get you to find the nth term, find Tn, find A, find R, whatever it is. It doesn't matter. You're using the one formula, and you've got different pieces of information. Your job is to figure it out. The hard ones are worded ones, because you have to write out your equations, and then simultaneous it. That's the only hard part. But you did that in 4B and 4C. It's the same thing for 4D. You just learned a formula, they're just trying to get you to work around with them. Yeah? So let's read this question here. It says, for a geometric sequence, so now you know it's a sequence, it's a pattern, where there's only multiplications. The first term is 18, so they told you T1. T1 equals 18. And the fourth term is 144. Okay, so T4 equals 144. Now they want you to find the common ratio. So what are they asking? They're saying find R. So previously they didn't say find R, they gave you A and R. Now they're saying, I gave you couple of extra pieces of information, I want you to find R. So, let's write it out. We've got A, first term is 18. T4 equals 144, but I can rewrite T4. Because according to the formula, T4 is equal to A, which I already know. I don't know what R is, but I know N. N is my 4. So I can rewrite it like this. I can say, well, T4, N is 4, R to the power of 4 minus 1. So now I just got R to solve. So let's work this out. T4, they told me that is equal to 144. So I'm like, all right, it's 144 here. That's 144. That's 18. Inverse operation. So if that's times 18, divide both sides by 18. 144 divided by 18 gives me 8, but I still have 4 minus 1, which is R cubed. And I want to find R, not R cubed. So you cube root, which is the opposite of cubing. And cube root of 8, therefore, gives me R equals 2. See what I mean? Okay, so one formula, and they're just trying to get you to work around. You'll find A, you'll find R, you find N. That's the whole point of this whole exercise, and then find A and R. So you're going to have to do simultaneous, yeah? And my point of going through these examples is just to get you some tools to work in case you're kind of stuck on how do you solve, how do you divide, how do you times, those kind of things, yeah? But it's just one concept, geometric sequence, yeah? Let's do another one. Here we go. They're getting progressively harder. But each one is giving you a different piece of information. Yeah? So for a geometric sequence, 36, 18, 9, the nth term is 9 out of 16. So now you're trying to find n. So what was the first one? First one was find out the value. The second one was find r. Now you're trying to find n. Okay, sounds hard, but it's not. Write out your piece of information. You're starting off with 36. You want to figure out, what's the common ratio from 36 to 18, from 18 to 9? What are we doing? What are we doing? Halving. Half of 36 is 18. Half of 18 is 9. But remember, it's geometric means multiplication. So what you're really doing is you're saying 36 times half. Then 36 times half. That gives you 9, okay? Half of 36 is 18, half of 18 again is 9. Yeah, so we've got a pattern. We've got a formula, and we've got a pattern. So here we go. We know common ratio is half. We know it's starting off with 36. We know this is our formula. What we don't know is what is n. But we do know the nth term is 9 out of 16. So we want to figure out n. So if I put it all together, I've got A, I've got R, I don't know what n is, but I do know the results. For Tn, T of n has to be 9 to the 16. So that's what I do. I'm like, all right, well, 36, R, And what should my Tn be? They told you it's 9 out of 16. You're trying to find n. So I'm like, all right, 9 out of 16. My job is to find n. Okay? And the same thing. We're now trying to solve for n. So divide both sides by 36. Maybe the fractions will scare some students. You know, 9 out of 16 divided by 36. A lot of students will get confused on how to do that. But remember, when you divide, you do the reciprocal, and it ends up being 9 out of 16 times 1 on 36. And that's why I've got the second line here as 9 over 16 times 36. That's why. Okay, so I know we're dividing both sides by 36, but just remember when you divide fractions, it's the same thing as saying multiplying the denominator by 36. Yeah? And you get this large number using your calculator. It'll be 9 out of 576. If you use your calculator, which I didn't figure this out, using a calculator I did, 9 out of 576 simplifies down to 1 out of 64, which is perfect. It's what I want. Now, if you remember from, if you're doing methods right now, which you should be if you're doing SPECH, this is now reminding you of exponentials and logs. Yeah? That's a base half. You want to somehow write this in a base half 2 or base 2. So you can think about it. 1 out of 64 is the same thing as saying 1/2 to the power 6. If you didn't know that, another way of thinking about it is this is the same thing as saying 2 to the power of -1 and minus 1. And 1 out of 64 is the same thing as writing 64 to the power of -1. And then you go through your 2's times tables. So double 2 gives you 4, double 4 gives you 8, double 8 gives you 16, and double 16 gives you 32, and conveniently double 32 gives you 64. So we know it's 2 to the power of 6. So another way of thinking about it is 2 to the power of 6 is equal to 2 to the power of -1 to the power of n minus 1. And they're all base 2, so that means the powers have to be the same, and you can equate them and solve. So there's just exponential skills here. 6, that's 2 to the power of -6, equals to 2 to the power of -n plus 1. And because bases are the same, and they're both equal, you can say -6 has to equal to -n plus 1, and you can solve that. Yeah? Alternatively, you can do what we did up there. So the nice thing doing about this is you don't have that -n. But they both come out to be the same answer. You see, you've got -6 equals to -n plus 1. Add n on both sides, so you got n equals to 6 plus 1. I'm just adding an n on both sides. 6 plus 1 is 7. So I know n has to be 7. But you could have done it this way too. You could have said 6 equals to n minus 1, and 1 on both sides, n equals 7. Same thing. But that's an exponential skill down. Yeah, so what you learned in methods, try and do. So what was hard? The theory isn't hard. Concept isn't hard. What was hard? Algebraically. It's all about your algebra. So all your skills that you learn in methods and since year 7 is to help you solve problems. You're getting all these tools and your job is to figure out how to do them. So you have simultaneous equations as well, and your job is to, how do you do them? Yeah? Now, last example. Is this the last one? Wait, the third term. Yeah, that's the one I want. There's the one, so most of you will be able to get the equations. It's then how to solve. It all goes back to exponential and logs, because you're timesing, dividing, you have the power, so it's exponential rules. So I want you to have a go with this one. Same thinking. What happened here? Did I not record, or what is this? That's weird. Why is there this? I don't know. Whatever. Formula. This is an example of a simultaneous equation. Just write down what you have. This is third term, 10th term, or 6th term, sorry. Two equations, simultaneous. It's a bit different just because you don't have addition, subtraction. You have times. You want, I'd use elimination method. You can use substitution if you want, but I like elimination. It's quicker.
Find the common ratio. means find. So, when it means find the common ratio. Oh no, and. Okay.
Find A and R. That's what you're trying to do. Those are your first two equations to start off with. You don't have A, you don't have R. I told you the third term is 10, so I know this equals 10. I just know that's 3. I just know that's 6. So that means your first two equations should look like that. And the question is, how do you solve this? You can't add or subtract, because if you add or subtract, it's a problem. That's different powers. It's not what you're used to. But that's the thing, if in arithmetic you add, the opposite of adding was subtract. Then to remove times, and it's divide. And that's what I would do. I would say, well, let's call this equation 2, the one with the 80, let's call that equation 2, equation 1. Then opposite, if you want to remove one of the variables, divide them. Because that's times, then divide. See, if I did 80 divided by 10, 80 divided by 10 gives me 8. A divided by A is 1. That cancels out, that's what I wanted. I'm eliminating. And then r to the power 5 divided by r squared. Don't be scared. It's the same thing. That's the same thing as saying that. That's what you learned. Year 7, index laws. Yeah? Saying r to the power 5 divided by r squared. And that conveniently now gives me r cubed. So, that's what I know. And then finally, r equals 2. You know R, you can now find A. How? Substitution. So back in. And so substitute R equals 2. So back into the first one or the second one, doesn't matter. You're just trying to find A. So 10 equals A times 2 to the power of R. I did it wrong. Yeah. So that makes it 4A. And A equals to 10 out of 4. A equals to 5 on 2. How did we go? Did we get that? Good. Last one before we finish today's session. Don't worry about this one. We'll just move on. You can work that out. All right, here we go. You can copy the example if you want, but logs, exponential logs, yeah? Geometric mean. If you remember arithmetic mean I told you there was a sequence. You have A, C, B, they're consecutive. So like 2, 6, and then 18. If you have an arithmetic mean, then you have a geometric mean. Geometric mean just means that middle number between the last and the first. The formula is given by C equals root of AB. Don't want you to memorize it, think about it logically. Yeah? Because we're talking about multiplication from A to C, it's multiply, and then from C to B, it's the same multiplication. Then to find out that common ratio, divide them. It's opposite of times. If you times, then it's divide. So logically, if I said C divided by A, it has to be the same thing as B divided by C. Logically. It's like saying 6 divided by 2 should be the same thing as saying 18 divided by 6. See, 18 divided by 6 is 3. 6 divided by 2 is 3. Well, how do I know it's going to be the same? Because 2 times 3 gives you 6. 6 times 3 gives you 18. It's just moving back and forth. Yeah? So this is all they're trying to summarize. They're saying that next number, which is C divided by A, should be the same thing as saying B divided by C, the same value. Now from here, how did you get C equals root of AB? It's the same thing. Solve for C. See, if I times C on both sides, see if I times this by C, times this by C, C divided by C cancels out, and I get C squared on A equals to B, actually that's just B, and then times both sides by A, times this by A, times this by A divided by A cancels out to be 1, so C squared equals to A times B, and C equals to root of AB. Makes sense? Yeah? There is no need to memorize all this, it just makes sense. If you understand what a geometric sequence is, hence geometric mean, you can figure out how to do the ratio. Yeah? But there you go. That's your geometric mean and that's it. So, chapter 4D, these are the questions. I've tried to pick one of each skill that you just went through, and that should be enough for you to understand chapter 4. Okay? So make sure to revise, because I'm going to keep drilling it in. You've got only 4 skills, well now 5. You have recurrent sequences, infinite sequences, arithmetic sequence, arithmetic series, geometric sequence. They all mean the same thing. Yeah, they all follow the same idea. One's times, one's add. All right. All right, thank you.